Geometric series are really, really nice. I think you'll learn to like them as we go on because they're one of the least complicated series. They have a certain form, and that form looks like this. If n starts at 0, going all the way up to infinity, and some constant c times r raised to the n power. This is called the common ratio. This is just a coefficient, some c value, and we have the exponent. So this is actually going to converge, and we have a specific formula. But there's another way to write geometric series, and that's like this, or from some number m, where m is just some integer that's not 0. It can be anything. It's still a geometric series. And then we'd have c times r to the n still. And it's evaluated the same way. Basically, this doesn't have to be 0, is what this is saying. And we have the same formula for convergence. So we can say if, and we'll take a look after some examples, but if the absolute value of r is less than 1, then the geometric series converges, and it converges to this formula. The first term divided by 1 minus r. And we'll take a look at things when this is not true, and we'll hopefully see why it is true when they converge. Or if this is true, then it'll converge, and if it's not, then it won't. So this one's like for geometric series, you'll be able to definitely tell, does it converge or diverge? There's no inconclusive result. So let's take a look at an example. All right, evaluate this. Now, it might not look like a geometric series at first, but remember, we want to write it as c times r to the n. So in this case, I'm just going to take care of this negative exponent. Remember, negative exponents means you flip it over, make it a fraction, and then it becomes positive. So this would actually look like something like this. I'm just going to keep working here, which is, well, I guess 1 over 5 to the n. Now, this still doesn't look like a geometric series so far, but I'm using my rules for exponents. 1 to the n is just 1. So, actually, I can rewrite it like this. I suppose now my r value, r is 1/5. My c value is just 1. So that's nice. And there we go. There's the geometric series. And r, or the absolute value of r, is less than 1. So this definitely converges. So now we are allowed to use the first term. What's the first term in this sequence? Well, the first term would be when I plug in 0. So 1/5 to the 0 power is 1, times 1 is 1. Divided by 1 minus r is 1/5. I'm just using that formula because this is true. If this was not true, then I know it diverges and I can't use this. So you got to check this first. And then that equals 1 divided by, well, this would be 5 over 5 minus, that would be 4 over 5. Flip the second one and multiply. So that would be 5/4. Easy. Now, we can think of this as converging. This is just, if let's look at, actually, we'll do that later. This, if this is less than 1, the absolute value is less than 1, then it converges and we can use that formula. If not, then you cannot.